Hello students! So this lesson here in this video is going to be an introduction to transformations. Some of you may be familiar with what transformations are and what types of transformations there are, but then there may be others of you, my students, who may not be so familiar with what transformations are. So again, I'm going to give you an introduction to what transformations are. So first off, let's just begin by stating that a transformation is a transformation of a geometric figure, or a transformation of, because it doesn't have to be of a geometric figure. It could be a transformation of a mathematic relation, or the graph of a mathematic relation or mathematic function. But a transformation is a function or a mapping that results in the change in position, shape, or size of a figure. So again, a transformation is a mapping or function that results in a change in the position, shape, or size of a figure. So here we go. Are you ready to meet transformations? Here's your formal introduction. Transformations meet students. Students meet transformations. Now don't act like I haven't tried to introduce you to somebody later on, okay? All right now. All right. So next up, guys, we want to just kind of make sure that you understand some basic things about transformations. And so, guys, for any type of transformation, whatsoever, you are always going to have what we call a pre-image, and we're always going to have what we call an image. Guys, a pre-image is that figure, or the original figure of pretty much what it looks like before any transformations occur. So that's what a pre-image is. Pre, again, that prefix pre. So again, that pre-image, that's going to be that original figure or original object before any transformations occur. While the image is going to be what that object or what the figure looks like after your transformations have occurred. So again, guys, we're always going to have a pre-image and an image when we're doing any type of transformations in math. And so, guys, again, you can sort of think of this sort of as like a before and an after, right? We always see these little commercials or advertisements where you see people who've had these extreme makeovers, where you see this before picture and then this after picture, right? So your pre-image is like that before picture, before any transformations occur, and the image is like that after. You're like, whoa, I don't even recognize, is that even the same person? Well, that's the whole point of a transformation, right, folks? It may not look the same, right? So again, guys, some of you may already know, again, what those specific or what the four basic types of, or four basic transformations are that we'll be discussing here in this class. There are more than four, but again, we'll just kind of be discussing four of those basic transformations. And again, like I said, some of you may have already heard of them, and you may just have called them different things. You may have called them, by different names. But again, guys, so some of you might be looking at these, you're like, oh, these look sort of familiar. Okay, so if you guys are looking at this picture that I have here with the purple triangles, then you're probably saying, okay, it looks like this darker purple triangle is being slid or moved up and to the right. So some of you might have referred to that as like sliding. Now, sliding is not necessarily a wrong name, but it is not a formal mathematic name for this type of transformation. The formal mathematic name for when an object slides, the formal mathematic name for that is called a translation. So this is a translation, and again, it is this figure sliding, but again, it's called a translation. So again, guys, that figure or that picture that you see with the purple triangles is a translation, and again, that translation is a shifting or sliding. But again, the formal name for it is a translation. It's a shifting or sliding of a figure horizontally, which means left or right, vertically, which means up or down, or it could be diagonally. And again, diagonally is a combination of horizontal and vertically. Again, guys, horizontal is left or right, and vertically is up or down. All right. So, guys, the picture that you're seeing with the red triangle, and it has a much lighter, almost translucent looking, or almost a clear looking red triangle, and then a darker one. Some of you might be looking at that picture of that red triangle, and you guys might be saying, "I've seen that before." That triangle is being spent or turned in a particular direction. Mr. Starkey, that's a spin or a turn, and some of you may have referred to this as a spin or a turn or something else. But again, guys, the formal name for this type of transformation is called rotation. So again, guys, this is a rotation, and again, it's a spin or turning of a figure. And that spinning or turning of this figure is usually around or about a fixed point. And so again, guys, so a rotation, that's the formal name for it. We're talking about this picture with the red triangle. That's a rotation. It's a spinning or a spinning or a turning about a fixed point or around a fixed point. And guys, that spinning or turning is usually in one of two directions, either counterclockwise or clockwise. Now, if you don't know what clockwise and counterclockwise is, now I know we got a new age going on where a lot of folks don't even have watches per se, and you might just use your cell phone. But back in the day, when we didn't just have digital clocks or just cell phones, we actually had analog clocks where we could see the two hands, the minute and the oh Lord, am I losing y'all? Where we could see the minute and the hour hand, and you could see which direction those two hands are going in. The direction that those two hands go in, that's clockwise. For those who don't know, but again, I'll talk about that in just a little bit, okay? All right, so again, guys, that picture there with the red triangle is a rotation. It shows a rotation. And again, that's a turning or spinning of a figure. And that turning or spinning is usually about or around. Now, guys, sometimes they may use the preposition about, and sometimes they may use the preposition around. Yes, I know what a preposition is. Just because I teach math don't mean that I don't know some English terminology. Don't try to play me like that. Now, again, sometimes they may use the preposition about, sometimes they may use the preposition around. But again, that spinning or rotating or turning, and again, the formal name for it is rotation. But again, that spinning or turning is usually about a fixed point. And sometimes, guys, they'll say that you're rotating it about the origin. And again, we know that the origin is that point in the middle of your coordinate plane. The origin is that point 0, 0, where the x-axis and the y-axis meet. But again, it's usually rotating around a fixed point. And again, that rotation, guys, is going to be either clockwise or counterclockwise. Okay? Do you know what clockwise is? Tick, tock, tick, tock, tick, tock. Right? The hands on the clock go clockwise, clockwise, clockwise. Right? So for those who may not know, who really, for real, who really may not know which direction clockwise is, let me help you out here, okay? This right here is clockwise, in that direction right there. That's which way the hands on the clock go, clockwise, like that. You see it? Tick, tock, tick, tock. You see which way my arrow going right there? All right, and then counterclockwise is in the exact opposite direction. Counter, against, or going the opposite. Counterclockwise, right? Going in the opposite direction. Okay? So again, you got your clockwise direction, the same way that the hands on the clock go. And for those who've never ever seen an analog clock, and I don't see how that's even possible. But anyway, for those who may not have ever seen an analog clock in your lifetime, because you just so digital age with your cell phone and your computers and your digital clocks and everything like that. But anyway, so again, that's a rotation. And again, the next figure, or the figure with the green triangle there. That figure with the green triangle. Some of you might be looking at those triangles there, and you might be saying to yourself, "I've seen this before." And so you might be saying, "Okay, this it looks like this triangle, that green triangle, or is being flipped over that line." Mr. Starkey, this is just this triangle being flipped over something. Okay, now, so guys, flipped over is not really a technical or formal name. Okay, the formal name for this transformation is a reflection. Okay, we're not talking about you looking in the mirror, but again, it is sort of kind of like something being reflected in the mirror, because in the mirror it's pretty much going to look the same way, except for it's going to kind of be sort of the opposite way. But anyway, it's talking about a reflection over, and usually what we're talking about here is a reflection over a line, okay, over some kind of line. Now, guys, it could be a reflection over the x-axis. It could be a reflection over the y-axis, a flipping over, a reflection over that. Or it could be some other, or I wouldn't say just some random line, but again, it could be any line. It could be some other type of vertical line that a figure is being reflected over, especially if we were talking about on a coordinate plane. It could be some other type of vertical line that's not the y-axis. It could be some other horizontal line that is not the x-axis that is being reflected over. And again, they could reflect it over a diagonal line as well. A diagonal line is one that's not vertical and one that's not horizontal. Now, if I got to explain vertical and horizontal again, a vertical line is one that goes straight up and down, y'all, and a horizontal line is one that goes straight across, left and right. Okay, all right now, let's get it together now. So again, guys, that picture with the green triangle is a reflection, and again, the reflection, that's the formal name for this. And that's a flipping of a figure. And again, guys, we're usually talking about a figure being flipped over or about, because again, they may interchange that preposition. Sometimes they may use the word over, and sometimes they may use the word about. But again, you're flipping a figure over or about either a vertical line, a horizontal line, or a diagonal line. Usually, it's talking about reflecting something over a line, at least. And again, it's doing that. It's reflecting this image, or reflecting this figure in such a way that, guys, the pre-image and the image are going to be equidistant. Now, I should not have to break down what the word equidistant means. If you just listen to the two parts of that, I don't think anybody will have any trouble with figuring out what we mean when we say right? You see this word written actually in that picture, that blue word written in the picture right there where it says equal, right? So that's the part that's right? Equidistant. What does distant sound like? Distant sounds like distance, right? Okay, so we're talking about the pre-image and the image being an equal distance from the line of reflection. And again, guys, that line that is being reflected over or about is called a line of reflection. And again, guys, you can refer to it also, that line, you can refer to it as an axis of symmetry as well. Now, guys, this is not the first time that you've heard of axis of symmetry, right? Because when we were doing quadratics and looking at those graphs when we were looking at those graphs where we had parabolas, again, guys, we talked about an axis of symmetry. And guys, you only have an axis of symmetry like this, or a line of reflection, if there is some type of reflectional symmetry. In other words, if it looks like part of your image is pretty much the same on both sides of the line of reflection. Yeah. Ain't no other way to put that, duh. But anyway. All right, so guys, this last picture that you're seeing here with the, let's see, what color is that? No, it's not orange. Beige, tan, beige, tannish, I don't know. Peach, no, it ain't peach, not quite. But anyway, that funny looking color right there, beige, tan, whatever it is. Somebody probably got a better color name for that than beige or tan, but whatever, that's all right. Inti este mundo. So this image or picture here with the beige or tan triangles. Notice how, guys, this one is actually the only one out of those four pictures, the only one where those two triangles look like they're a different size, right? Yeah. All right, so we'll come back to that. We're going to put a pin in that with the different size part. But anyway, so guys, some of you might be looking at this picture here, and you might be saying, I've seen this before. Mr. Starkey, if one of these is a pre-image and the other one is an image, if one of these is the before and one of these is the after, then Mr. Starkey, this right here is this figure being stretched or shrunken. Okay, so it's being stretched or it's being shrunken, or in other words, it's being enlarged or it's being reduced. There's a reduction or an enlargement or a stretching or shrinking. Now, none of those words that I just said, stretching, shrinking, enlargement, reduction, none of those words are the technical or formal name for this transformation. The formal name for this transformation is a dilation. Say it with me, y'all. Dilation. You guys have heard the word dilation before. If you've ever been to an eye doctor and he put those little drops in your eyes, and then afterwards you couldn't hardly see worth nothing. Yeah, he put those little drops in your eyes, and then you ask him, Doc, what you just do to my eye? Oh, he'll say, I dilated your pupil. That drop, it dilated your pupil. And so now when the eye doctor says that, when he says dilate, he's specifically talking about stretching. But again, dilation could be either a stretch or shrink, or in other words, it could be an enlargement, which makes something bigger, or it could be a reduction, which makes something smaller, right? So again, that's that fourth different type of basic transformation. Okay, and again, that's called a dilation. Okay, so again, guys, this picture here with the beige or tan, khaki triangles is a dilation. And again, guys, that is a stretching or an enlargement or a shrinking or reduction of a figure. So again, it's either stretching or shrinking. In other words, the figure is going to get bigger or smaller, right? And guys, usually when there's a dilation, a shrinking or a stretching, usually there is pretty much a focal point. And again, we mean like there's a certain point that kind of is sort of the I guess the main focus point of where that dilation is coming from. And again, what we call that focal point we call it the center of dilation. Now, guys, in this picture that you're looking at here with the beige or tan or khaki triangles, you should be able to kind of use a little bit of common sense there and sort of see what that focal point or center of dilation is there. Now, if you said that O, yes, that point that is labeled as point O, so if you're saying that point O is the center of dilation or your focal point for this dilation in this particular image or picture, then you're correct. O is the center of dilation there. Now, guys, again, as far as center of dilation is, let me kind of give you another example. Have any of you guys ever been playing around with like a flashlight or something like that? Maybe it's dark and you just playing around with a flashlight, telling ghost stories, or making like a little what do they call puppet shadows, making like little shadow puppets on the wall or something like that. You got a flashlight and you got your fingers in front of the flashlight. All right, and so when you do that, guys, the source of the light, that flashlight, the source of that light is that center of dilation. So if you're looking at the image there, imagine that point O right there. Imagine that point O is the source of the light, is that flashlight. Okay? And imagine that small triangle there are your fingers. And you're making a shadow puppet up against the wall. So again, you got the flashlight, you're using your fingers in front of the flashlight, and guys, usually when you do that, the farther away you get from the source of that light, the bigger that shadow becomes up against the wall, yeah, and so again, guys, yeah, that's the way that dilations work, or at least that's one way you can think of a dilation where you've probably seen that before. Okay, but anyway, so there's a center of dilation, just like the flashlight when you're making like little shadow puppets or whatever up against the wall. And guys, there's always a scale factor. Now, for those who may not know what a scale factor is, guys, a scale factor is pretty much a number. Well, yeah, it's a number that tells you precisely how much larger, or in some cases, how much smaller the image is than the pre-image, right? So let's say if the scale factor was 2 or something like that, that means, guys, that your image is twice as large as your pre-image. If the scale factor was 2, that means pretty much that the size is 2 times bigger for the image. Okay? The size of the image is 2 times bigger or larger than the pre-image if the scale factor was 2. Okay, and then of course, if you had the opposite thing there and the scale factor was something like 1/2 or 1/3 or something like that, then that means that the image would be 1/3 the size of your pre-image. Okay? And guys, that's the way the cookie crumbles. Okay, so guys, we said that we were going to put a pin in talking about how one of these particular types of transformations is a little different than the other ones, right? So we coming back to that right now, okay, right now. All right, so which one of these transformations does not belong with the rest of them? Okay. All right. Is it the translation? The rotation? The reflection? Or the dilation? So, which one of those 4 transformations does not belong with the other ones? Which one? Which one needs to be kicked out of the group? That's it, y'all. You got it. You got it. Well, y'all smart. Y'all is smart. I heard you. I heard y'all say it's a dilation, Mr. Turkey. That doggone dilation, it don't belong with them other ones. That dilation, it's got a pre-image and an image that's completely different sizes. But all of the other transformations, the translation, the rotation, and the reflection, those 3, they're sort of kind of the same, because the pre-image and the image, they pretty much are still the same size, right? You called it, y'all. Yeah, that dilation is different than the other 3. So, guys, the dilation is different than the other 3, like you probably said. And again, it's different because that dilation is not an isometry. I'm going to say that again. The dilation is not an isometry. Now, I know that sounds like a funny word, right? And we're gonna break it down. We're gonna break down the word isometry. Isometry. Now, it's got 2 parts in that word. Iso, sort of like isosceles, right? Iso, which means the same or equal, right? And then metry, or like, and metry is sort of like metric, right? Or so iso is same. Metry or metric is sort of like measure, right? So we're talking about where they have the same measurements, the exact same measurements. And isometry is a transformation, guys, that pretty much preserves all of the measurements. It preserves your side lengths. It preserves your angle measurements. In other words, guys, it preserves your shape and your size. Okay? And so those three types of transformations, translation, rotation, and reflection, those are all clumped into a category of types of transformations that we refer to as isometry. Okay? Okay, so again, guys, a dilation is not an isometry. And again, for those who may not know or may not have known, an isometry, again, folks, is a transformation that preserves both the shape and size. Okay, so again, if we're saying that that an isometry is a transformation that preserves both the shape and the size, in other words, it keeps the shape the same. In other words, those angle measurements should be the same for the pre-image and the image, and also the size should be the same, meaning the side lengths, or it could be that we're talking about the perimeter, which is the total distance around it, a figure, or if it was a circle, we could be talking about the circumference could be the exact same, but again, the size of it is the same, as well as the shape is the same. So since that's what an isometry is, where the size and the shape are the same, what that means is that whenever we have an isometry, that means that your pre-image and your image are going to be congruent. You guys remember the word congruent? Congruent figures? But anyway, so again, where your shape and size are the same. Again, the positioning of the figures might be different. Like you may have one that slid or shifted over here or over there, or you may have one that was turned or over here, or you may have one that was reflected or rotated or translated. Again, but again, the shape and the size are going to be the same, which means that your pre-image and your image are going to be congruent figures in an isometry. Again, folks, with an isometry, your pre-image and your image will always be congruent figures. So again, your before and after will always be congruent images, congruent figures with an isometry. And so what that means is that only isometries, only those types of transformations that preserve both the shape and the size, only an isometry can produce congruent figures. Okay? So only isometries can produce congruent figures. And so guys, we know that a dilation is not an isometry. And again, guys, a dilation is not an isometry because even though a dilation preserves the shape, so again, a dilation does preserve the shape, meaning that it preserves those angle measurements, but guys, a dilation, by definition, a dilation does not preserve the size, because in order for it to be a dilation, it has to be an enlargement or a reduction. It has to get bigger or it has to get smaller in order for it to be a dilation. So a dilation is not an isometry. It's not an isometry. Again, because a dilation does not preserve the size. Okay, and so again, guys, when you have a type of transformation that only preserves the shape, but again, it produces a figure that is either bigger or smaller, but again, that shape is preserved. Those types of figures that have the same shape, but where one of them is bigger and one of them is smaller, those types of figures are called similar figures. So again, I'm using this opportunity here to segue into what's the difference between congruent figures and similar figures. Yes, folks, because an isometry will produce congruent figures, but a dilation will produce similar figures. So again, guys, when we have a dilation is going to preserve the shape. Okay, and again, you can see the image here. A dilation is going to preserve the shape, but not the size. So again, because that happens in a dilation, with any dilation, guys, the pre-image and the image will be similar figures. And again, that means that they have the same shape but different sizes. And so, guys, only a dilation can produce similar figures like that. And again, only isometries can produce congruent figures. Folks, that's it. That's all I got for you. I hope that this video has been helpful to you. I hope that it has been a great introduction. And again, like they say, I introduce to some and present to others. So for those who may have already known all about transformations, then we just representing it to you. But again, I do hope that this has been helpful to you. That's it. That's it, folks. Good night. Bye. Arrivederci. Adios. Ciao. Bye-bye.